object to move. So we have studied this. So but they have to go through what is a force. So for the object, it's not too heavy. We can push it and then change the motion. So basically, the force is something capable of changing motion. This is the language is very simple. If something is changed, the motion change, then that must have a force acting on it. So this object is rest right now. So if I want him to move, then like this, then I need forces to make the changes. So you can say in another term, in which case a change of motion, is evidence of force. That means that something is changed in motion is obviously is evidence of the forces existing. So a lot of times the force is cannot do it. For example, right now I push it. Okay. Now the reason why I push it, the object is not in motion, is due to one fact. There's another force push me back. In this case, it's called reaction force. I push it and then push back. This is the one is too heavy, so it cannot move. So the whole table doesn't move. So Isaac Newton keeps studying this. So he says how I can explain it very nicely. So he come up with the things is in this world there's something is always rest. If you don't touch it, don't move it, then he says then you're creating a law, Newton's first law. We will do this Newton's first law the next week. He says an object when it's at rest is remain at rest, and an object in motion is continuous in motion with constant velocity. So now this one he understood means that the object is travel in a straight line. If you go to change in a circular motion, they must have a centripetal force, as we talked before. So in order to make the object change, you have to need forces. No force, no changes. And this says something is resistant to the resist to change. Something is a resist to change. So Isaac Newton find this out. Something in an object resists to change. What is a resist to change? It is called mass. The more heavy the object is, the more difficult for it to move. So the mass is resistant to change. So we give a name, in which case it's called inertia. So when you move, when we want an object to move linearly, there's an inertia to push it back. Then there's another inertia, in which case it's related with rotation. Anything related with rotation, then you have another inertia, in which case it's called moment of inertia, to resist the rotation. So in the future, we will study another motion, it's called rotation. But right now, we concentrate the motion in the straight line. So the heavier the object is, the more resistant to change, more resistant to have a motion. Now you looking at the nature. The nature already tell you a lot of it. A small, when the object is very, very small, when the animal very, very small is more active because it doesn't carry too much mass. So typically, like a hummingbird, that is a very large motion. The one have a lot of mass, it can move very fast. Typically, if you look at the Shaquille O'Neal, especially 10 years ago, you can tell because he has a thick mass. He doesn't want to move. He's just waiting at what we call under the basket, and somebody push him, give him the ball, but he make a lot of money. So the larger the mass is, the more inertia is. The same thing with Michael Jordan. Right? Michael Jordan is very fit. He jumped like this. We give a name called Michael Air Jordan. It's the same way. He's very fit and they move very fast. So for the whole society, we need what we call the people with proper fitness. In our class, it's very nice. Everybody is skinny. So in their cases, you don't take too much SAD, Standard American Diet. So you are okay. So don't get out of control. So as soon as you get out of control, you keep eating it, then you get in trouble with the body. So that's the first law. So now we say, okay, what happened to the force? What happened to the force? So the force, we already know. Force will cause motion. So in this case is the Newton's second law. Newton's second law. He is not the first one inventing this. Isaac Newton is the one who put all the things together. He's becoming like an organizer. Of course, after he done that, he get all the credit about it. So we like to say, if an object under the force in motion, so what does it change? Change motion. What is a changing motion? It's called acceleration. In order to change motion, you gotta have acceleration. So Newton's second law say acceleration is proportional to the force. So the larger the force is, it will give us the largest acceleration. So since the force is a vector, association is a vector as well. And then in directional, proportional to the mass, what we call so he written the thing based on this. He written that association equal to force divided by m. So we have written in this form originally. Later on, we converted that force is equal to mass times acceleration. So he, immediately, the gentleman, Isaac Newton, creating a new unit. What's the new unit? Means the unit of force. Unit of force, he says, 1 Newton is equal to 1 kilogram times 1 meter per second squared. So the unit is very important in physics. So in the test, we stress on that. If you have a wrong unit in the answer, we deduct 5 points, or at least 25% of the test. Okay, so if you get the wrong answer, of course we deduct 25%. So that is the cases, by the way. So this is the situation related with Newton's second law. So ladies and gentlemen, a lot of you say, oh guys, the F equals ma, so simple. What's so good about it? Very good. Have been proven is very successful. So sometimes my son doesn't like farm. Farm means a restaurant book. And then I told him, you are a son of a farm. I'm farm, so he's my son. He's the son of farm. Okay. Okay, now the next thing we will go to is in the Earth, we have what we call gravitation. Gravitation and force pushing. But in here, we didn't go through it, but we might as well go through it. So the gravitational force is another presentation of Isaac Newton for gravitation force and weight. So what Isaac Newton keep looking at is apples. So the apple keeps looking toward the center of the Earth. He said this must be something close the apple drop toward the center of the Earth. A suggestion. So gravitation law says if you have mass m1, if you have another mass of m2, the separation by this by r, then Isaac Newton's version of gravitational force is F sub g is proportionally to m1, m2 divided by r squared. That is gravitational. He didn't finish. He working on this Newton worked on this in 1666, something around there. It takes almost 150 years. So that's why I keep to emphasize one thing. Do some lab. Okay? Do some lab. So in order to for engineer to successfully do the lab, make a product, you gotta know the lab. And by doing that, make your hand dirty, you learn something physically, knowing the past and so forth. Don't become a person, even though he's an engineer, he doesn't know how to handle the screwdriver. Then that would be very bad news. So he proposed this. F sub g is proportional to that. In 1798, the gentleman is called Cavendish. I consider in this contribution, Cavendish have making more contribution than Isaac Newton for this law. So some textbook, they say Cavendish gravitation law, in which case it is properly stated. So when you're doing this experiment, it's nothing fancy. It's just using a wooden ball, a big wooden ball, and then using galvanometer and very sensitive electrical device. And you can measure the G very accurately.